Hello everyone, it's a pleasure meeting you again in my mathematics class. Today let me do the problem finding the inverse Laplace transform of 1 by s plus 1 into s square plus 4 using convolution theorem. This can be done using partial fractions also, but I have exclusively or particularly taken this problem to use the convolution theorem. See, what is that? We know that L of f of t convolution g of t. Convolution g of t, this is equal to L of f of t multiplied by L of g of t, that is equal to f of s multiplied by g of s. This is the convolution theorem, and therefore L minus 1 of f of s into g of s is equal to L minus 1 of f of s convolution L minus 1 of g of s, that is equal to f of t convolution g of t, and f of t convolution g of t is equal to 0 to t of f of u into g of t minus u du, or 0 to t g of f of, you can even write g of u into f of t minus u into d. So this is all about the convolution theorem, and using this small knowledge of convolution theorem, let me explain how this problem could be done using convolution theorem. Okay, now see, we have to find this now L minus 1 of, see, L minus 1 of s plus 1 into 1 by s square plus 4. This is equal to, so this is L minus 1 of s plus 1 convolution L minus 1 of 1 by s square plus 4. So this is equal to, so this is nothing but e to the power of minus t convolution, this is nothing but half into sine 2t. So because since L minus 1 of s square plus 4 is equal to half into sine, see, half into L minus 1 of 2 divided by s plus 1 whole square, that is equal to half sine 2t. So that is why I have written here half sine 2t. Now see, now f of t convolution t of t is equal to, I will write this as half sine 2 tau into e to the power of u, this is u, I will write it as u, or 2 tau we can take, and it is e to the power of minus t plus t minus tau into d tau. So this is equal to e to the power of minus t into integral of 0 to t, you can take this half also outside. It is e to the power of tau into, it is sine 2 tau into theta. But this is a well-known integration that this is nothing but it is 1 into tau. So this is e to the power of minus t divided by 2 into this is e to the power of tau divided by 1 square plus 2 square into 1 into sine 2 tau minus 2 cos 2 tau. This one must be raised to 0 to t. This must be the limit from. So this is a standard integration that I have straight away applied the integration here. So you get this. So this is nothing but, see, this is e to the power of minus t divided by 2. And here you apply this e to the power of t, e to the power of t divided by, it is 5. Then it is sine 2t minus 2 cos 2t minus, if you apply the second limit, it is e to the power of 0 is 1, so 1 by 5 into, if you put tau is equal to 0, sine 0 is 0, and this is minus 2. So you apply the limit, upper limit t, so you get e to the power of t. It is divided by 5 sine 2t minus 2 cos 2t minus, it is e to the power of 0 is 1 by 5 into, this is 0, it is minus t. So this is equal to, you will get this as e to the power of minus t divided by 5, e to the power of t by 5 sine 2t minus e to the power of t cos 2t divided by 5, e to the power of sine 2t divided by 5 minus this plus 2 by 5 minus the minus. Now you take this, that is f of t composition, that is convolution, f of t convolution g of t is equal to, take this inside, e to the power of minus t plus t is 1, so 1 by 10 into sine 2t minus, again this is 1, this is 2, so this is sin, this is 2, here you see that it is e to the power of t by 5 sine 2t, it is 2 cos 2t here, so it is e to the power of t 2 cos 2t. So when you take this inside, this is 1, 2 and 2 goes off, giving you cos 2t divided by 5. Then when you take this inside, you get this to be plus e to the power of minus t divided by 5. So this is the answer for f. Therefore, the convolution by f of t is 1 by 2 sine 2t minus 1 by 5 cos 2t plus. So this is it. That is how I have done is, here I have explained this. See, we know that I told you that it is nothing but L of, it is f of t convolution g of t, it is equal to, it is L of f of t multiplied by L of g of t, that is equal to L of s multiplied by g of s. Therefore, L minus 1 of f of s multiplied by g of s equal to, it is nothing but your f of t convolution g of t. So this is what I have done here. See, f of t convolution g of t I have written here completely. So you see that this is nothing but your e to the power of minus t and half sine 2t. I have written in this way, and I have applied the integration. This is a standard integration, and I can derive that also. So I have applied here. Then after applying the limits, I go for the simplification. Finally, I get f of t convolution g of t is equal to 1 by 10 into sine 2t minus, that is, this is nothing but your convert. This is, that is L minus 1 of, this is s plus 1 into s squared plus 4, s squared plus 4 is equal to, so this is equal to your 1 by 10 sine 2t minus cos 2t divided by 5 plus e to the power minus t divided by 5. So this is that. So this is all about this problem. Here what you have to know, this convolution of two functions you must know, and how this is written, convolution of two functions is written, how it is written you must know, and then do this integration must be well known, you get the answer. So this is my first problem. I will do the next one in the same lines. So this is a problem, and you have, here also you have to use the convolution theorem. Now here I will write here, see, L of, see, L minus, see this S can be written as what? S by S squared plus A squared. We have S squared is equal to S by S squared plus A squared 1 by S squared plus A squared, and L minus 1 of S by S squared plus A squared is equal to cos 80. You call this as, and L minus 1 of 1 by S squared plus A squared is equal to 1 by A into L minus 1 of S squared plus A squared is equal to 1 by A into sine 80, call it as g of t. Therefore, L minus 1 of, see, L minus 1 of this S by S squared plus whole square is equal to L minus 1 of, it is S divided by S squared plus A squared convolution L minus 1 of 1 divided by S squared plus A squared, that is equal to L minus 1 of, it is nothing but cos 80 1 by A into sine 80, that is equal to f of t convolution. So L minus 1 of S by S square plus A square convolution L minus 1 of 1 by, but the inverse Laplace transform of this is cos 80, and this is 1 by A into sine 80. Therefore you get f of t convolution g of t. Now we have to find what is this. Now we know that now f of t convolution g of t is equal to, it is nothing but what? 0 to t. This is nothing but, you can write this as your cos, I will write this as cos a tau into 1 by a into sine of a t minus tau into d tau. This is the as per definition of convolution of two functions. As per definition of convolution of two functions. Now this is nothing but what? So I will write this as 1 by 2a. I will write this as 1 by 2a 0 to t 2 sine a t minus a tau into cos of a tau d tau. So this is 2 sine a cos b, that is equal to 1 by 2a integral of 0 to t. It is sine of, this is a and this is b, sine of a plus b, at minus a tau plus a tau plus sine of at minus a tau minus a tau into d tau. This is what you get. So this is nothing but what? So this is equal to 1 by 2a. It is 0 to t. It is nothing but, see, sine, this and this goes off, giving you sine 80 plus this is sine of 80 minus 2a tau into d tau. This is what we get. So this can be written as 1 by 2a 0 to t sine 80 d tau plus 1 by 2a 0 to t into sine 80 minus 2a tau into d tau. So what is that I have written here is, so f t convolution g of t is, f of t I have got here cos of 80 and this is sine of a. So I apply the convolutions here and therefore cos of a tau into 1 by a into sine of t minus tau into d tau. And I multiply this by 2 and divide it by 2 so that I can get this as 2 sine of this into cos a tau, that is 2 sine a cos b. But 2 sine a cos b is sine of a plus b plus sine of a minus b. So I apply that identity. So you see that I am getting this as 1 by 2a into sine 80, a minus a tau plus a tau goes off, sine 80 plus sine of 80 minus 2a tau. So you split this into two integrals. Now this is equal to, you see, so this is equal to 1 by 2a into sine 80 into sine 80 into integral of 0 to, see, because sine 80 with regard to this variable of integration, it is a constant, so you take that outside and remove it, and this one, you know, plus 1 by 2a, and if you integrate this is minus cos 80 minus 2 tau divided by minus 2a. And it is 0 to t. So if you apply the limit here, this is simply tau. So it is nothing but 1 by, I will write it here. So it is 1 by 2a sine 80 into tau 0 to t. Here you see that minus, you can remove it. So it becomes plus. So it is plus 1 by 2a. Within brackets you get this as, see, minus into minus is plus, so you get this cos 80 minus 2a tau, and the limit is from 0 to t. So this will be equal to, if you apply the limit here, it is t, so it is nothing but 1 by 2a into t into sine 80. If you apply the limits here, it is, if you put t here, it is, see, if you put t here, so what will happen here? Plus 1 by 2a. Apply the first limit, it is minus, so it is at minus 2at, that is minus 80 will get, but cos of minus theta is cos theta, so you will get this as cos of 80 minus, if you put 0 here, tau 0, that means this 2a is the 2a into tau will be 0, it is minus cos 80. So you get this to be, this is 0, this is 0. So what is that you get here? 1 by 2a into t into sin 80. So what is that I have done here is, see here I have put here convolution of two functions, because I told you that this inverse Laplace transform of this is equal to the convolution of two functions f of t and g of t. F of t into g of t is equal to 0 to t. I apply the convolution way of writing integral and I have written here. After that I have multiplied this by 2 and I have made it as 2 sin a cos b. But 2 sin a cos b is sin of a plus b plus sin of a minus b. I have used that identity and I made the simplification. After that you see that sin 80, this is independent of this tau. So you see that sin 80 can be removed outside and do the ordinary integration. This integration is simply tau. So I have written here tau. And the integration of this is minus sin of sin theta integration is minus cos theta. So it is minus cos 80 minus 2a tau and divided by minus 2a. And limits are from 0 to t. When you apply that 0 to t, what happens is that when you put here t, this 80 minus 280, that is, you get cos of minus 80, but it is cos of minus theta is cos theta. So I am getting it as cos 80 minus, if you apply 0 here, so tau 0 means it is 0. So simply it is cos 80. So cos 80 minus cos 80 is 0. So this second term becomes 0. So you get 1 by 2a into 2 sin 80. Therefore, what is the answer for this? Therefore, L minus 1 of s by a square plus a square is equal to, it is 1 by 2a into t into sin 80. So this is how we do using convolution theorem. So the only thing that you must know is what is convolution theorem, how it is applied, and also how to this that is the integration here, how it should be done. The integration here, small manipulations have to be done in order to do the simplification. Then we will get the answer. So we will see more problems in the coming days. Thank you.